200 million people. That is the number AccuWeather released this morning, updated just hours ago. 200 million Americans now sitting inside the reach of the most widespread heat event the eastern half of this country has seen all summer long. And here is the part that keeps me staring at these model runs. This is not a one-day temperature spike. This is not a weekend warm-up that fades by Monday. What is parked over the centre of this country right now, and what is about to bulldoze eastward straight through the 4th of July holiday weekend, is a full-scale, week-long atmospheric siege. The kind of event where your overnight low in Philadelphia might not drop below 80 degrees for 4 consecutive nights in a row. The kind where the heat index in Nashville at 2 in the afternoon touches 110 and calls it a Tuesday. The kind that emergency managers plan for months in advance and still worry they are not ready for when it actually arrives. And the kind that, once you understand what is generating it, raises a much larger set of questions about where this summer is going. Questions I am going to try to answer for you today with real data. I want you to understand something before we even get into the numbers. Every single heat wave you have experienced in your lifetime eventually ended because the atmosphere kept moving. The jet stream pushed through. A cold front swept down from Canada. The lid came off the atmosphere and cool air flooded back in. What makes this event different? What makes me look at this particular setup with a level of attention I reserve for the most consequential weather situations of any given year is the mechanism holding us underneath it. This is not ordinary summer heat building under a standard afternoon ridge. This is the product of 2 separate high-pressure cells merging into a single enormous lid over the centre of the country, a blocking pattern with the atmospheric depth and persistence to hold firm through the Independence Day weekend, and an upper-level configuration that both the European ensemble model and the American GFS have been remarkably consistent about through multiple runs over the past 72 hours. When those 2 modelling systems agree on something this far out, and keep agreeing with every new run, I take that as a signal that the core of this forecast is on solid ground. They are agreeing right now. They have been agreeing all week. I also want to say this plainly before we go any further. Extreme heat is the deadliest weather phenomenon in the United States. Not hurricanes, not tornadoes, not flooding. Heat. It kills more Americans every single year than all of those combined. We're entering the most dangerous stretch of this summer so far, affecting more people simultaneously than any other weather event this year, and I want to make sure you come out of this video with the science and the specifics to navigate the week ahead safely. Here is how I am taking you through this. I am going to lay out the day-by-day picture first, because this week has a very specific timeline, and I want you to know exactly when your window of danger opens, what the peak looks like for your region, and when relief starts to arrive. Then I'm going to pull the camera all the way back and show you the bigger machine running underneath all of it. The atmospheric mechanics, the El Niño fingerprint on this entire summer, the planetary scale blocking pattern, and what is happening simultaneously on the other side of the Atlantic right now that tells us something important about where the season is going. And then, at the close of this video, there is a tropical angle to this story that most people are missing entirely. The heat dome itself may be setting the stage for something along the southern Atlantic coast, and over the Gulf waters during the first week of July. I will walk you through that connection with the National Hurricane Center's own language from this morning's official tropical weather outlook. Let us get into the data. Today is Sunday, June 28th. Right now, this morning, the core of the high-pressure ridge is anchored over the central Gulf Coast states. Temperatures across southern Mississippi, Alabama, and the panhandle of Florida are already climbing into the low 90s through the morning hours. The dew points in that region are running in the upper 60s to near 70 degrees. That combination, air temperature in the low 90s alongside dew points near 70, produces heat index values that will reach 105 to 108 degrees through the peak afternoon hours. If you are in Biloxi right now, if you're in Mobile or Pensacola or Tallahassee, the effective temperature your body is managing is not 92 degrees. It is closer to 107. That distinction is not a footnote. That is the difference between discomfort and a genuine physiological threat, especially for anyone over 65 years old, anyone with cardiovascular or respiratory conditions, and anyone working outdoors for extended periods today. But today is not the peak. Today is the opening act of a 7-day production. The critical thing I want you to hold in your mind as we walk through this timeline is this: heat waves kill in cumulative fashion. the first day of a heat event is rarely the most dangerous. It is day 3, day 4, day 5, after the human body has been unable to fully recover through multiple consecutive warm nights, that heat-related illness and death peak. The event we are entering today will not reach that cumulative danger threshold for most of the affected population until Wednesday through Friday. That means decisions you make now, today, about your cooling resources, your check-in plan for vulnerable neighbours and family members, and your own activities schedule through the week matter more than any individual day's forecast. Monday, June 29th, is when the architecture of this event begins revealing itself across a much larger swathe of the country. The ridge axis shifts northeast. The dome's eastern flank begins compressing into the Ohio Valley and the Tennessee Valley simultaneously. Chicago reaches 92 degrees on Monday. Louisville, Kentucky hits 95 with a heat index of 103. Memphis, Tennessee, already managing heat through the weekend, approaches 100 degrees for the first time this summer. Cincinnati comes in at 97, Indianapolis at 93 with a heat index pushing into the upper 90s. Lexington, Kentucky reaches 98. Evansville, Indiana gets to 96. These are not cherry-picked outlier cities in some distant corner of the map. These are the population centers of the Ohio Valley, and nearly all of them will be experiencing the hottest days of their summer simultaneously starting Monday. The detail I want you to lock into: the overnight lows on Monday night will stay in the upper 70s to near 80 degrees across most of these cities. Louisville 79 overnight, Cincinnati 77, Nashville 81. When the low temperature at 3 in the morning in Louisville, Kentucky is 79 degrees. That is warmer than a pleasant summer afternoon in many parts of New England. Something critical has broken down in the natural cooling cycle that human health depends on. Your body uses the nighttime hours to reduce its core temperature and allow cardiovascular and respiratory systems to recover from the strain of extreme daytime heat. When overnight lows stay above 78, that recovery is incomplete. The heat debt accumulates. By Wednesday, the population most at risk is the one that has been unable to cool down for 2 consecutive nights. Drop your city in the comments right now. Tell me where you are watching from and what your current temperature is. I want to know who is already inside this zone this morning, Tuesday, July 1st. Both the European model and the GFS show the ridge centered squarely over the Ohio Valley, approximately over a line from St. Louis east to Columbus. That position puts the very hottest, most compressed air of the entire event over a region that has not yet experienced a prolonged, dangerous heatwave this summer. This matters in a physiological and a public health sense. A population that has been managing repeated 90-degree days for weeks is in a different state of acclimation than a population experiencing its first serious heatwave of the year. The Ohio Valley, the Great Lakes, much of the Mid-Atlantic and the Northeast. These areas have had a relatively moderate June by historical standards. The sudden arrival of temperatures 15 degrees above normal after weeks of near-normal conditions is more dangerous from a population health standpoint than the same temperatures arriving in August, when the body has been acclimating since Memorial Day. St. Louis on Tuesday approaches 100 degrees. Columbus, Ohio reaches 96 with a heat index above 100. Nashville approaches 103 on the heat index. Pittsburgh gets to 93, surprisingly warm for a city that often escapes the worst of mid-Atlantic heat events. Cleveland reaches 91 with elevated humidity. Detroit gets to 94. And the I-95 corridor from Washington northward is now fully inside the dome's eastern reach. Washington, D.C. is forecast to hit 100 degrees or higher. AccuWeather's senior meteorologist Alex Sosnowski confirmed in a forecast updated this morning that Washington may have highs at or above 100 for as many as 4 consecutive days. Philadelphia climbs to the century mark, and AccuWeather projects 2 to 3 consecutive days above 100, despite average highs in the upper 80s for this date. That is a 12 to 15 degree anomaly sustained over multiple consecutive days in a city where the infrastructure for heat response, cooling centers, shade, public water stations, was not built for a 3-day run at 100 degrees in late June. Overnight lows in Washington, Philadelphia, and Baltimore will struggle to drop below 80 degrees through the heart of the heat wave. AccuWeather's meteorologist Brandon Buckingham stated this explicitly. Some of the larger cities may not drop below 80 at night at the height of the heat wave. Urban areas retain heat because pavement, concrete, and brick absorb solar energy during the day and release it slowly overnight. The long daylight hours of late June amplify this urban heat island effect. Newark, New Jersey has a better probability of hitting or exceeding 100 than New York City does because of the concentration of concrete, asphalt and industrial surface cover in that specific part of the metro area. New York City itself could reach 100 for a couple of days in the middle of the week, which would be the highest temperatures recorded in New York City since 2013. I want to pause here because the latest GFS run raised a scenario I need to address directly. There is a fork in the model guidance for the Washington, D.C. area specifically, a scenario where the ridge centers itself further south and west, versus a scenario where it sits directly overhead. Scenario A, where the ridge center is south and west, puts Washington on the edge of the dome rather than under its center. Edge of the dome positioning means higher instability and a greater risk of brief but violent afternoon and evening thunderstorm complexes, what meteorologists call ridge riders. These are not cooling events. A ridge rider thunderstorm complex in a heat dome environment can produce damaging winds of 60 to 80 miles per hour, large hail, and lightning, followed almost immediately by a return to the oppressive heat. The storm passes in an hour, and the temperature goes right back to 95. Scenario B, where the ridge sits directly overhead, suppresses all storm development and drives even hotter, drier, more persistent heat. The America 250 celebrations on the National Mall on July 4th are directly in the forecast uncertainty zone between these two scenarios. Fox 5 meteorologists in Washington have explicitly flagged this as the critical wildcard for the holiday. Either the temperatures are slightly lower because ridge riders keep cycling through, or the temperatures are slightly higher because the dome stays firmly clamped overhead. Either way, the heat is dangerous. July 2nd is when the latest guidance shows the ridge beginning its slow, reluctant westward retreat. I want to be very precise about what slow means here. This is not a dramatic collapse of the blocking pattern. This is a drift of 1 to 2 degrees of longitude per day in the center of the high. The eastern seaboard does not suddenly cool. As the center of the ridge shifts west, its eastern trailing edge continues dragging northward along the I-95 corridor. Boston, which may have partially escaped the early part of the heat event, starts climbing into the upper 80s and low 90s by Wednesday into Thursday. Portland, Maine reaches the mid-80s. Burlington, Vermont pushes to near 90 degrees. New England gets pulled in late, just as the center of the event is beginning to ease over Ohio and Pennsylvania. The geography of this week is such that no part of the eastern half of the country gets to skip it entirely. The dome passes over you on its way in or on its way out. July 3rd and July 4th. The holiday window carries complexity on multiple levels, and I want to give it the time it deserves. The Climate Prediction Center issued a high risk of extreme heat designation specifically targeting July 4th. Their advisory covers the eastern Great Plains, the Mississippi Valley, the Ohio and Tennessee valleys, the Appalachians, the Southeast, and the Mid-Atlantic. A broader moderate risk extends from the Great Plains all the way to the East Coast. A slight risk covers much of the Great Basin, the Rockies, and more distant parts of the eastern United States through July 7th. The CPC noted explicitly in their advisory language, and this is unusual, that a key consideration is the nation's 250th anniversary on July 4th, with numerous outdoor activities planned across the country. Philadelphia's Wawa Welcome America Festival, New York Harbor's Sail 4th 250 celebration, with dozens of tall ships, the National Mall celebrations in Washington. Tens of millions of Americans outdoors for extended periods during what is forecast to be the most intense stretch of heat in this entire event. The absolute thermal peak, the worst of the dome's compression and intensity, is expected around Wednesday, July 2nd and Thursday, July 3rd. Washington, D.C. may not get meaningful relief until late on July 4th or into July 5th. AccuWeather projects Boston could begin cooling before the 4th, while Washington holds the heat longest. The Southeast, Atlanta, Charlotte, Raleigh, Memphis, Nashville, holds the high temperatures into the holiday weekend itself. Nashville and Memphis remain in the upper 90s through July 4th, based on current guidance. Let me also walk you through something the models have been showing about the internal movement of the ridge, because the day-by-day position of the dome's axis matters for understanding who gets the worst heat and when. On Sunday today, June 28th, the ridge axis runs approximately from central Texas northeast through Kansas City and into southern Michigan. The maximum subsidence, the most intense sinking and warming, is along and south of that axis. The Gulf Coast states are fully under the lid. The Ohio Valley is beginning to feel the eastern expansion of the dome but has not yet reached peak intensity. On Monday, June 29th, the ridge axis rotates and shifts northeast. It repositions from northern Louisiana through Tennessee into Pennsylvania. That movement means the highest pressure, the strongest subsidence, and the most extreme temperature anomalies are now directly over the Mid-South and lower Ohio Valley simultaneously. Memphis, Nashville, Louisville, Lexington, Cincinnati, Columbus. These cities are now at or near the thermal bullseye of the entire event. Chicago sits on the western periphery. Pittsburgh is inside the warm zone. Washington, D.C. is being pulled in from the east as the dome's clockwise circulation wraps moisture and heat northward along the coast. On Tuesday through Wednesday, July 1st and 2nd, the ridge axis pushes further northeast still. It now runs from central Tennessee through southern Ohio and into New Jersey. This is the peak configuration. The bullseye is simultaneously over the Ohio Valley and the Mid-Atlantic. Philadelphia, Washington, Baltimore, Richmond, Columbus, Pittsburgh, all of them are at or near their maximum heat simultaneously on Tuesday through Wednesday. This is the period AccuWeather and the National Weather Service are most concerned about from a public health standpoint. On Thursday, July 3rd, the ridge has reached its maximum northeastern extension and is beginning to show the first signs of westward retreat. The axis is migrating back from New Jersey toward the Virginia and Tennessee corridor. The heat remains intense across the entire affected region, but the rate of change is beginning. The northeast starts seeing the first tentative circulation of slightly cooler air sneaking around the weakening ridge from the northwest. On Friday into Saturday, the retreat accelerates. The heat abandons the northeast but does not leave the country. It retreats westward toward the Central Plains and Mississippi Valley. The southeast, Tennessee, Mississippi, Alabama, Georgia, continues running well above normal through the holiday weekend. The heat dome is not breaking down in July's first week, it is migrating. I also want to address the GFS versus European model disagreement for this event, because it is worth understanding clearly. The European ensemble mean has been running slightly cooler than the GFS deterministic for the peak of this event, specifically for Tuesday through Thursday. The European mean is placing the ridge center slightly further west and slightly weaker than the American model guidance. That produces a peak temperature solution in the Ohio Valley and Mid-Atlantic that is approximately 2 to 3 degrees cooler than the GFS is showing. 2 to 3 degrees in a heatwave context is not trivial. The difference between 98 and 101 in Columbus, Ohio, or between 97 and 100 in Philadelphia, represents a meaningful difference in mortality risk and public health response threshold. I trust both models on the broad architecture of this event. The dome is real, the duration is real, the scope is real. Both models agree on all of those things with high confidence. Where the uncertainty lives is in the precise peak temperature on the worst days in individual cities. The GFS is likely running a degree or two warm, the European is likely running a degree or two cool. Reality will probably verify between the two solutions. For public health planning, the advisory message does not change materially based on which model verifies. Both solutions are dangerous, both warrant the same preparation. Now I want to talk about the cities on the boundary of the forecast uncertainty, the ones where model disagreement leads to meaningfully different outcomes: Roanoke, Virginia, Knoxville, Tennessee, Chattanooga, Tennessee, Huntsville, Alabama. These cities are not the primary focus of most heat dome coverage, but they sit in a geographic zone where the difference between the two model solutions leads to genuinely different forecast outcomes. The GFS puts Roanoke near 100 degrees on Tuesday and Wednesday. The European ensemble keeps it in the upper 90s. For anyone in these intermediate cities, I recommend planning for the GFS warm scenario. The downside of preparing for heat that turns out to be slightly less severe is that you drank extra water and stayed inside an extra afternoon. The downside of not preparing for heat that turns out to be more severe is real and irreversible. Now, I also need to address the western dimension of this story, because the dome is not only affecting the eastern half of the country. West Texas, New Mexico, Colorado, Utah, and Wyoming are on the western and northwestern periphery of the dome. These areas are not experiencing the extreme high temperatures of the Ohio Valley and Mid-Atlantic. But the pattern change driving the heat dome eastward is simultaneously pushing a strong flow of dry, warm air across the Intermountain West, elevating fire weather conditions to critical or extreme levels through the first week of July. The Cottonwood Fire east of Beaver, Utah, has burned through an area roughly the size of Salt Lake City in just a few days and remains at 0% containment. The Iron Fire near Eureka, Utah, has burned more than 40,000 acres. Utah's Governor Spencer Cox imposed a temporary fireworks restriction through July 5th. In the fire weather environment across the Intermountain West this week, a single spark from a fireworks display in the wrong location is not a trivial risk. It is a scenario that fire management agencies are genuinely worried about ahead of the 4th of July holiday. If you are in Utah, Nevada, Western Colorado, or Wyoming this week, the fire weather risk is your headline, not the heat dome. Be extremely careful with any open flame or heat source. Be aware of local fireworks restrictions. Have an evacuation plan if you live in a wildland-urban interface zone. Now I want to pull back from the calendar and show you the atmospheric machine generating all of this. The core mechanism is a blocking pattern. The high-pressure ridge that has established itself over the central United States, sometimes called a death ridge in meteorological shorthand, creates a column of sinking air extending from the surface all the way up through the middle troposphere over an enormous geographic area. High pressure means atmospheric descent. When air descends, it compresses. When air compresses, it warms without any external heat source. The scientific term is adiabatic heating. Under a deep, strong ridge, that sinking and compressing motion alone can push surface temperatures 20 to 30 degrees above seasonal norms. The current event is running approximately 15 degrees above normal across the core of the Ohio Valley, which falls within the expected range for a ridge of this depth and persistence. The subsidence inversion is the physical mechanism that makes this feel like a lid. As warm air sinks and compresses toward the surface, it creates a stable boundary layer, a temperature inversion where the air gets warmer as you move upward from the surface for the first 1,000 feet or so, rather than cooling as it normally would. That inversion acts as a physical ceiling on the atmosphere below it. Cloud development beneath the inversion is suppressed because rising surface air hits the warm inversion layer and cannot continue rising to form cumulus towers. Without clouds, solar radiation reaches the surface unimpeded for the entire day. Without rain, the ground dries out. Dry ground has much lower heat capacity than moist ground and heats up faster because it cannot cool itself through evapotranspiration. Hot, dry ground radiates heat back into the boundary layer, which strengthens the inversion above it, which suppresses the clouds that would otherwise reflect some radiation back to space, which allows more solar heating, which dries the ground further. This is a positive feedback loop that can strengthen a heat event day over day, and it is exactly the dynamic the models are showing for the core of this dome from Monday through Thursday. Now here is where El Niño enters the picture, and I want to spend real time here because I believe this is the most underrepresented piece of the scientific story in this event's coverage. Before I explain El Niño's role, I want to make sure you understand what the Nino 3.4 region is, because I will reference it throughout the rest of the summer season. The Nino 3.4 region is a rectangle of ocean in the central equatorial Pacific, roughly centered between about 170 and 120 degrees west longitude and 5 degrees north and south of the equator. It is the primary monitoring region for El Niño and La Niña. Warm sea surface temperature anomalies in that region, departures above positive 0.5 degrees Celsius sustained for several months, define an El Niño event. The Nino 3.4 index was approaching positive 1 in early June. Climate models project it to continue warming through summer and into early fall. That puts us on a trajectory toward what NOAA might classify as a moderate El Niño by late summer, possibly stronger if the Kelvin wave activity currently propagating eastward through the subsurface Pacific delivers a thermal pulse to the surface as projected. Why does this matter for your air conditioning bill and your personal safety this summer? El Niño does several things to North American atmospheric circulation simultaneously. First, it energizes and extends the Pacific jet stream further east than it sits in neutral conditions. A more eastward Pacific jet displaces the polar jet and the mid-latitude storm track, favoring ridge building over the central and eastern United States. This is why El Niño summers often produce above normal temperatures across much of the country during the warm season. The ridge that is trapping heat over the Ohio Valley this week is a textbook El Niño period circulation response in terms of its type and position. The details of its specific amplitude and timing vary, but the tendency for ridges to build over the center and east of the country is a documented El Niño teleconnection. Second, El Niño raises baseline tropospheric temperatures across the northern hemisphere. The global average temperature in El Niño years typically runs above the long-term mean for that year, because the warm ocean in the central Pacific is continuously transferring heat into the atmosphere. That elevated baseline means that any individual heat event, any ridge that builds and traps air underneath it, produces higher temperatures than the same ridge pattern would in a neutral or La Nina year. This is what I call the El Niño tax on heat events, and it is measurable in the data. Third, and this is the piece that ties directly to what the Climate Prediction Center, NOAA, and Colorado State University are saying about the rest of the summer, El Niño strengthens the subtropical jet stream across the southern United States. A stronger subtropical jet increases wind shear across the Gulf of Mexico and the Caribbean Sea, which historically suppresses Atlantic hurricane activity during El Niño summers. This is why the 2026 Atlantic hurricane season is forecast to be below normal by multiple institutions. Strong El Niño means strong shear over the main development region of the Atlantic. But simultaneously, that same enhanced subtropical jet carries enhanced moisture from the Pacific across Mexico and into the southern tier of the United States, fueling the southwestern monsoon and driving elevated severe weather risk across the southern and central plains. I am telling you all of this not just as background science, but because it shapes what the rest of this summer looks like. The heat dome you are watching this week is one expression of El Niño at work. The enhanced monsoon flow that will drive flooding rains into New Mexico and Arizona in July is another. The below-normal Atlantic hurricane season is a third, and the elevated risk of intense heat events continuing through August and into early September is a fourth. El Niño is the underlying story of the 2026 warm season. This week is its most dramatic chapter so far. There is a sea surface temperature detail that I also want to draw your attention to, because it is directly relevant to this specific week's event. The sea surface temperature anomaly map over the Gulf of Mexico and the Western Atlantic right now is running above normal. Not dramatically above normal. This is not the boiling Gulf of 2 or 3 years ago, at the height of an extreme marine heat wave. But surface temperatures across the Gulf waters, across the Florida Straits, and from the Bahamas northward to the Outer Banks are at or above the seasonal climatological average for late June. That matters for 2 reasons. First, above normal Gulf sea surface temperatures mean the air mass flowing northward from the Gulf into the southern and central United States is carrying more moisture than it would if the waters were at normal temperature. Dew points of 68 to 70 degrees across Tennessee and Kentucky, and the mid-Atlantic are being sustained in part by that warm Gulf moisture supply. Second, and I will come back to this in the tropical section, above normal Gulf sea surface temperatures mean any low-pressure system that enters that region has access to the oceanic energy needed to sustain and potentially intensify tropical development. The Nino 3.4 index, the primary metric for measuring El Niño development in the central and eastern equatorial Pacific Ocean, was approaching +1 in early June. +1 on that scale is near the threshold of what NOAA defines as moderate El Niño status. The sea surface temperature anomalies in the equatorial Pacific south of Hawaii and hugging up along the coast of South America are running significantly above the long-term average. Warm water in the central equatorial Pacific energizes and extends the Pacific jet stream further east than it would be in a neutral or La Nina year. A more eastward extended Pacific jet creates enhanced ridge-building tendencies over North America, specifically over the central and eastern continental United States. The ridge you're watching this week did not appear in a vacuum. It was favored by the atmospheric circulation pattern that El Niño is pushing on the continent. But the El Niño influence on this event goes beyond the teleconnection that favored building the ridge in the first place. El Niño raises the baseline temperature of the entire lower troposphere across the northern hemisphere. The heat that gets trapped under a ridge in an El Niño summer is hotter than the heat trapped under a comparable ridge in a neutral year, not because the ridge is stronger, but because the air being compressed under the ridge started warmer before the compression began. Think of it as an El Niño tax that gets added to every heat event. Whatever temperature the ridge pattern is generating on its own, add the El Niño premium on top of it. In the current event, that premium is running several tenths of a degree above the neutral year baseline for this atmospheric configuration. That does not sound like much until you translate it into forecast impacts. That premium is why Philadelphia is looking at 100 degrees for 2 to 3 consecutive days instead of 1. That is why Washington approaches 100 for 4 days instead of 2. That is why overnight lows across the Ohio Valley are running 2 to 3 degrees warmer than a comparable ridge event in a neutral year would produce. El Niño is not creating the heat wave. It is making every heat wave this summer run hotter at the margins. The NOAA Climate Prediction Center's longer-range temperature outlook for the first week of July shows above normal temperatures across more than 30 states. The darkest probability shading, the areas where the CPC is most confident about above normal outcomes, covers a broad corridor from Minnesota south through Ohio, Indiana, Kentucky, Tennessee, and the Carolinas, extending to the Virginia and Maryland coasts. That is not one state or one region having an unusual heat event. That is half a continent running thermometrically hot simultaneously. Now let me bring in the European dimension, because it adds something to this story that purely American-focused coverage is missing. While the United States bakes under this ridge this week, Europe is simultaneously locked under its own blocking heat dome. The timing is not coincidental in the random events sense. It is a signature of the same planetary scale atmospheric configuration, expressing itself across both the North American and European atmospheric sectors at the same time. The European event is being driven by what meteorologists there are calling an omega block, named for the Greek letter omega, because the shape of the jet stream when it bends around a stationary high-pressure center traces that letter in the upper atmosphere. A ridge at the center, flanked by 2 low-pressure troughs, with the normal west-to-east progression of weather systems halted entirely by the stationary high. The European omega block has trapped an enormous mass of Saharan air over Western Europe for most of the past week, driving temperatures across France, Spain, Portugal, and southern England to levels that in some locations approach all-time late June records normally set in late July, not late June. Parts of France reached temperatures in the low to mid-40s Celsius this week. That is 110 to 113 degrees Fahrenheit. At least 18 fatalities have been attributed to the heat in France, including 2 children left in a hot car. Red alerts, the highest level of meteorological warning, have been issued across multiple European countries. The atmospheric connection to the American event is this. Both blocking patterns, the American death ridge and the European omega block, are expressions of the same amplified planetary wave pattern that favours building and maintaining stationary ridges across both the North American and European sectors simultaneously. When the planetary atmospheric circulation amplifies, when the north to south excursions of the jet stream become larger, slower, and more persistent, you can see simultaneous blocking on both sides of the Atlantic. 2 continents baking simultaneously in the same week is not unprecedented, but it is telling. Researchers who study atmospheric blocking patterns have documented that the frequency of these amplified configurations linked to extreme summer weather, including heat domes and flooding, has nearly tripled since the 1950s. They are becoming more common, more intense, more likely to arrive early in the season. I mentioned earlier in this video that there is a wild card for the holiday weekend that I would come back to. Here is the payoff, and this payoff has 2 parts. The first is the ring of fire severe weather threat that I have already partially described, and I want to go deeper into that before moving to the tropical dimension. The second is the tropical connection that most coverage of this heat event is missing completely. On the ring of fire front, the physics of how these thunderstorm systems form along the edge of a heat dome is something I want you to understand clearly, because it explains why the most dangerous days for the northern plains this week are actually some of the hottest days for the eastern United States simultaneously. The heat dome is not uniform from center to edge. At its core, directly under the axis of highest pressure, the atmosphere is most stable. Sinking air suppresses all convection. No clouds, no rain, no relief. The temperatures at the core are the highest. The dew points are the lowest, because sinking air dries the air column, and the wind is the calmest. Moving outward from the core, the atmosphere becomes progressively less stable. The sinking motion weakens. The boundary between the hot, dry air mass under the dome and the cooler, more humid air masses around its edges becomes a zone of intense atmospheric contrast. That contrast, meteorologists call it a baroclinic zone, produces the energy that drives severe thunderstorm development. The crucial piece is the clockwise circulation of the high-pressure system itself. That circulation acts as a steering current for the thunderstorm complexes that develop along the baroclinic zone on the northern and northeastern edges of the dome. The storms form, often in the afternoon or early evening, and then get swept along the periphery of the dome by the clockwise outflow winds. They can travel hundreds of miles overnight, maintaining or even strengthening as they move through an unstable environment, fed by the moisture-laden air on the outer edge of the dome's circulation. When a complex of this type maintains itself over hundreds of miles through the night, meteorologists call it a mesoscale convective system, or sometimes, if it maintains an organized bow-shaped structure and produces long swaths of damaging winds, a derecho. Derechos are among the most dangerous convective weather events that occur in the United States. A derecho can produce wind gusts of 70, 80 or 90 miles per hour across a corridor hundreds of miles long and sometimes hundreds of miles wide. The wind damage can resemble that of a weak hurricane passing over inland terrain. Power outages from derechos during heat events have historically driven significant mortality because communities lose air conditioning precisely when they need it most. The AccuWeather storm maximum wind gust estimate of 95 miles per hour for the current Ring of Fire arc on Sunday into Monday is consistent with a derecho strength event in the most intense part of the arc. The states I am watching most closely for derecho-level Ring of Fire severe weather through this week are South Dakota, North Dakota, Minnesota, Wisconsin, Michigan, and potentially Iowa and Nebraska on the western side of the arc. If you are in those states this week and you lose power, the heat risk adjacent to the severe weather risk is not a secondary consideration. It is the primary emergency management concern. Now let me get into the tropical connection, because I think this is genuinely important and it deserves a thorough explanation. The connection between heat domes and tropical development in the adjacent ocean basins is not widely discussed outside of academic meteorology. But it is real, it is physically grounded, and it is exactly what AccuWeather meteorologists and NOAA forecasters are watching right now in the context of this specific event. Here is the physical mechanism step by step. A large heat dome over the central United States generates a strong, broad clockwise circulation around its periphery. That circulation is not just a weather phenomenon over land, it extends across the water. The clockwise outflow from a dome centered over the Ohio Valley drives persistent south to southwesterly winds across the Gulf waters north of the Yucatan and south of Louisiana. It drives persistent southeasterly winds along the Atlantic coast from Florida to the Carolinas. Those winds do several things relevant to tropical development. First, south to southwesterly winds over the northern Gulf reduce the normal easterly trade winds. Reduced trade winds allow the Gulf surface to warm further. Already above normal Gulf surface temperatures get pushed even warmer by the reduced wind mixing. Warmer surface water means more oceanic heat available to sustain any tropical or subtropical low that develops in that region. Second, the heat dome's clockwise outflow creates a convergent surface wind pattern across the Gulf and along the southeastern coastline. Converging surface winds produce ascending motion. Ascending motion over warm water is exactly the condition that favors tropical cyclone organization. This is why tropical meteorologists track the outflow patterns of continental high-pressure systems during heatwave periods, because the heat dome circulation can create favorable conditions for tropical development in the adjacent oceanic zones, even when the synoptic scale environment over the open ocean would not otherwise favor it. Third, the stalled frontal boundary near the southeastern coast, the remnant of the front that the dome has pinned against the Atlantic coastline rather than allowing to push through, provides a focus for low-pressure development. Frontal boundaries in the subtropical Atlantic during summer are one of the classic genesis mechanisms for what NOAA calls subtropical or hybrid cyclones. These systems lack the purely warm core structure of a classic tropical storm, but can produce significant winds and rainfall, and, if they spend enough time over warm water, can transition to tropical cyclone characteristics. The National Hurricane Center's tropical weather outlook from this morning at 5 a.m. Eastern Time identifies precisely this scenario. A low-pressure area is expected to form offshore of the southeastern coast of the United States, along the western end of the stalled frontal system early next week. The formation chance through 48 hours is near 0%. The formation chance through 7 days is 20%. The potential storm Bertha would be the next named system of the 2026 Atlantic season, following Tropical Storm Arthur, which formed June 17th and has since dissipated. There is a second area AccuWeather is monitoring as well. As the dome's circulation continues to generate storm clusters along the Gulf Coast and along the southeastern Atlantic coast through the first week of July, some of those clusters will be passing over Gulf water temperatures that are above the 26 degrees Celsius threshold typically considered the minimum for tropical development. AccuWeather's Bernie Rayno broke this down in specific detail. The clockwise flow around the heat dome will steer these clusters westward across warm Gulf waters, and given enough time over those warm waters, the clusters could consolidate into an organized tropical or subtropical low. I want to be very precise about my framing here. 20% is not a high probability. I am not forecasting Tropical Storm Bertha. I am not forecasting a Gulf hurricane. I am explaining why the atmospheric system that is producing extreme heat for 200 million people is simultaneously creating the physical conditions that make tropical development in adjacent ocean basins physically plausible over the following week. These are not separate stories. They are the same high-pressure system expressing itself on both its interior, extreme heat, and its exterior, favourable conditions for tropical development. What I will tell you is that I am watching the southeastern Atlantic and the northern Gulf waters very carefully from July 1st through July 10th. If that disturbance shows signs of consolidating, the dew point trajectory across Florida and the Gulf Coast will be one of the first indicators. If the surface circulation tightens and the convection becomes more organised, the NHC development probability will rise above 20%, and I will have dedicated coverage for you immediately. For now, the tropical story is a watch item, not a warning item, but I wanted you to understand exactly why I am watching it, and why the heat dome and the tropical potential are the same story told from two different vantage points. The clockwise outflow from the high-pressure dome sitting over the Ohio Valley and Mid-Atlantic is not only driving heat into population centres, it is simultaneously generating two distinct atmospheric phenomena along the dome's edges that I want to explain clearly. The first is the ring of fire. Along the northern and northeastern edge of any large heat dome, instability is highest because that is where the hot, dry air beneath the dome meets the cooler, more humid air at the atmospheric boundary. Thunderstorm clusters develop along this temperature and moisture contrast zone and race along the perimeter of the dome, driven by the clockwise circulation. Meteorologists call these ridge riders. When they form along the edge of a broad, persistent heat dome, they can produce what is called a ring of fire pattern, an arc of severe thunderstorm activity stretching potentially 2,000 miles around the dome's perimeter. AccuWeather confirmed this morning that they are monitoring exactly this pattern. They describe a ring of fire arc of severe thunderstorms stretching from northern Mexico through the northern plains and curling through the Midwest into parts of the northeast and southeastern Canada. On today, Sunday, June 28th, the primary focus sits from southern Saskatchewan south through central South Dakota, across Minnesota, and through northern Wisconsin and Michigan. Damaging hail and high winds are the primary threats. AccuWeather's local storm maximum for wind gusts in this arc is 95 miles per hour. Monday's threat zone extends from the Dakotas through the upper peninsula of Michigan and into Nebraska and Iowa. These fast-moving convective complexes have the potential to produce derechos, long-lived, line of thunderstorms producing widespread damaging wind events covering hundreds of miles. What makes the ring of fire threat particularly serious in the context of this heat event is the power outage intersection. An intense mesoscale convective system tracking through Minnesota on Monday night that knocks out power to tens of thousands of homes creates a dramatically dangerous situation when temperatures on Tuesday reach into the mid-90s with high humidity. Homes without air conditioning in a heat wave of this intensity can reach indoor temperatures of 100 to 110 degrees within hours of losing power on a sunny, hot day. The cumulative risk of power outage plus extreme heat is one of the most dangerous weather scenarios that public health officials and emergency managers face. If you are in the northern plains, anywhere from northeastern Montana east through North Dakota, South Dakota, and into Minnesota and Wisconsin, you're on the ring of fire edge this week. Your temperatures will not reach 100 degrees the way the Ohio Valley and Mid-Atlantic will, but the derecho wind threat, the large hail threat, and the power outage risk in the context of the surrounding heat event creates a compound hazard that warrants serious preparation. The second atmospheric phenomenon the heat dome is generating along its periphery is even more significant from a longer-range perspective. This is the tropical angle I referenced at the beginning of this video, and it is time to explain it fully. The clockwise circulation around the dome drives persistent southeasterly winds along the Atlantic coast south of the dome center and persistent south to southwesterly winds across the Gulf waters west of the dome center. That circulation pattern does two things simultaneously. It steers moisture northward from the tropics into the Gulf states, sustaining the extreme dew points and heat index values I described earlier, and it steers any storm activity that develops along the stalled frontal boundary near the southeastern coastline in a westward or west-northwestward direction, straight across warm Atlantic and Gulf waters. AccuWeather meteorologists began flagging this connection publicly on June 25th and updated it again yesterday. The next named storm of the 2026 Atlantic season would be Bertha. Tropical Storm Arthur formed June 17th and has since dissipated. As of the National Hurricane Center's 5 a.m. Pacific Tropical Weather Outlook this morning, Sunday, June 28th, the NHC is tracking the following. A low-pressure area is expected to form offshore of the southeastern coast of the United States, along the western end of a stalled frontal system early next week. Slow development of this system will be possible thereafter, as it moves slowly westward. Formation chance through 48 hours, low, near 0%. Formation chance through 7 days, 20%. 20% is a low probability. I am not forecasting tropical development, and I am not forecasting a Gulf landfall. What I am doing is connecting two stories that are usually told separately but are in fact the same atmospheric story. The heat dome trapping 200 million people is also producing the clockwise flow pattern and the stalled frontal boundary and the enhanced warm water moisture pathway that makes early July tropical development along the southeastern and Gulf coasts physically plausible. These are not independent events. They are the same circulation system expressing itself in different geographic sectors. And because the Gulf waters and the western Atlantic from the Bahamas to the Outer Banks are running at or above seasonal normal sea surface temperatures right now, any low-pressure system that consolidates in that environment will have access to the warm water energy that sustains and potentially intensifies tropical systems. AccuWeather's lead hurricane expert Alex De Silva put it this way in a report earlier this week. The setup will deliver warm ocean temperatures and potentially favourable atmospheric dynamics for development along the Gulf Coast and southwestern Atlantic during early July. I will be watching the southeastern coast and the northern Gulf carefully through July 1st through July 10th. Now let me be clear about what relief looks like and when it comes. The latest GFS shows the ridge beginning its westward retreat around July 2nd into July 3rd. But slow matters enormously here. Washington, D.C. does not get meaningful relief until late on July 4th at the earliest. Philadelphia sees the break sometime on July 4th or 5th. New York City likely starts cooling July 3rd or 4th. Boston could begin cooling before the 4th. The Southeast, Memphis, Nashville, Atlanta, Charlotte, holds the heat the longest, staying in the upper 90s through the 4th and into the following weekend. The Ohio Valley starts releasing by July 5th through 7th as the dome slides west toward the Central Plains. The pattern after the dome retreats westward is also worth watching. When a blocking ridge of this duration begins to erode, the boundary between the retreating hot air mass and the incoming cooler air from the northwest becomes a severe weather focus. The atmospheric instability that the heat dome has been suppressing gets released rapidly as the inversion breaks down and cold air undercuts the warmth. The pattern change that ends the heat wave is often the same pattern change that fires the dangerous thunderstorm episodes that follow it. I am watching the window from approximately July 4th through July 8th for a transition from heat threat to severe weather threat along a frontal boundary stretching from the northern plains southeast toward the Appalachians. That is a forecast detail I will update as we get closer. Before I close, let me place this event in its proper scientific context, because the full picture deserves to be stated plainly. But first I want to spend a moment on something that I think is not getting enough attention in the broader conversation about this heat event, the specific vulnerability of communities and populations that are often invisible in forecast discussions. Heat mortality in the United States does not fall evenly. It concentrates in specific communities: elderly populations living alone, people without access to air conditioning, urban residents in neighborhoods with high pavement and low tree cover, outdoor workers who cannot stop working when temperatures rise, incarcerated populations with inadequate cooling, and low-income communities where the cost of running air conditioning through a week-long heatwave creates real financial hardship. When the forecast says 200 million people are affected, those 200 million people are not equally protected by the infrastructure available to them. The urban heat island effect compounds this inequity in ways that are rarely communicated clearly in mainstream weather coverage. A neighborhood in Philadelphia with dense brick row houses, minimal tree canopy, and dark asphalt streets can be 10 to 15 degrees hotter at night than a suburb 15 miles away, with green lawns and tree shade. The same heat dome that keeps downtown Philadelphia above 80 at 3 a.m. may allow a bedroom community 30 miles out to cool to the upper 60s. The forecast number, the citywide high temperature, does not capture that geographic inequity within urban areas. It is the reason that heat mortality in American cities disproportionately concentrates in specific zip codes, often historically redlined neighborhoods with less tree cover and more heat-absorbing infrastructure. I raise this not to turn a weather forecast into a policy lecture, but because I think the science of heat vulnerability is part of the atmospheric story. The heat dome you are watching this week is a universal atmospheric phenomenon. Its consequences are not distributed universally. If you are in a position to help a neighbor who is in a heat-vulnerable situation this week, that action directly reduces the human cost of this event. This is one of the strongest early-season ridge amplifications over the eastern United States I've seen in at least a decade. The combination at work here is unusual, even against the backdrop of historically active recent summers. 200 million people affected simultaneously. 7 days or more of duration for the core of the heat event. First significant heat wave of the summer arriving before widespread population acclimation. Simultaneous comparable blocking event across Western Europe. El Niño elevated baseline temperatures adding a calculable premium to every forecast number across the affected area. Ring of fire, severe weather threat wrapping the dome's northern edge. And a potential tropical development precursor along the dome's southern outflow corridor. All of those factors expressing themselves in the same week. None of those individual elements is without precedent. What is unusual is the convergence of all of them simultaneously, during the final days of June and the first week of July, against an El Niño background that is still building toward its peak intensity. This is not an isolated bad week of summer weather. It is a data point in a trend that has been moving in one direction for decades. More frequent, more intense, more geographically extensive heat events, arriving earlier in the season, compounded by El Niño phases that amplify everything they touch. The atmospheric science on this is not contested. The blocking patterns are more frequent, the ridges are more intense, the baseline is warmer, and the events that result are more dangerous across more communities than they were 30 years ago. What you do with that information this week is straightforward, but I want to be specific, because the difference between vague safety advice and actionable safety advice is the difference between information that is easy to dismiss and information that actually changes behavior. Hydration. The standard recommendation is 8 8-ounce glasses of water per day under normal conditions. During extreme heat with outdoor activity or physical exertion, that needs to be dramatically higher. Some sports medicine guidelines suggest a litre of water per hour during sustained outdoor exertion in temperatures above 95 degrees. The critical mistake most people make during heat waves is waiting until they are thirsty. Thirst is a late-stage signal of dehydration. By the time you feel thirsty in a heatwave environment, you may already be meaningfully dehydrated. The physiological rule to remember: drink before you feel thirsty, eat salty snacks to help your body retain fluid, and limit alcohol and caffeine, which accelerate dehydration. Cooling centers. FEMA and local emergency management agencies activate cooling centers during extreme heat events, but many people do not know where they are or do not feel comfortable using them. Your local library is a cooling center. Many community recreation facilities are cooling centers. Large retail stores are effectively cooling centers during their business hours. If the temperature in your home rises above 95 degrees and you do not have functional air conditioning, a cooling center is not a luxury. It is a potentially life-saving resource. Check-in systems. Most heat fatalities involve social isolation. Elderly people dying of heat-related illness in their own homes, often without anyone checking on them for days. If you have elderly neighbors, elderly family members living alone, or anyone in your social network who lacks air conditioning, make a specific plan to check in on them once or twice a day through Thursday. A 10-minute visit or a phone call to confirm they are okay costs almost nothing. The failure to make that check-in can cost everything. Outdoor workers. If you work outdoors in any capacity, construction, landscaping, agriculture, delivery, road work, the heat index values forecast for Tuesday through Thursday represent genuine risk. OSHA heat illness guidelines recommend a minimum of 1 cup of water every 20 minutes during heavy outdoor work in temperatures above 94 degrees, with mandatory shade breaks of at least 10 minutes for every 2 hours of outdoor work. Know your rights as a worker during extreme heat. Know your employer's heat illness prevention plan. And recognize the early warning signs of heat exhaustion: heavy sweating, cold and clammy skin, fast weak pulse, nausea, muscle cramps and dizziness, which precede the far more dangerous heat stroke. If you are in the heat zone, and if you're anywhere in the Ohio Valley, the Mid-Atlantic, the Southeast New England or the Northern Plains, you're in the heat zone in some form. Drink water before you feel thirsty. Find cool spaces before the afternoon peak heat arrives. Know where your nearest cooling center is. Check on elderly neighbors, on family members without working air conditioning, on anyone who might need help getting through the next several days. The data on heat mortality is clear. The people who die in heat waves are most often the people who are isolated, without cooling, without someone checking on them. A phone call matters. A knock on a neighbor's door matters. Are you in an area that has not seen heat like this before this summer? Is this your first real heat event of 2026, and do you have what you need to get through it? Leave it in the comments. I read them, and I use what you tell me to better understand what the people watching this channel are actually facing on the ground. My name is Arthur, and I have been tracking this event closely since the models first developed consensus on it 5 days ago. If you are new to Sky Space Lab, this channel exists to bring you the atmospheric science behind the numbers, not just the advisory level, but the mechanism, the context, and the broader pattern that produced the event you're living through. Subscribe if you want that level of coverage every day this summer. Click the bell so you get notified when new videos drop. I post every day when something significant is happening, and the next several days absolutely qualify. If this breakdown gave you genuine value, share it with someone you know who is in the heat zone. Like this video if the science and the specifics added something to your picture of the week ahead, and subscribe to Sky Space Lab if you're not already here. This channel is committed to bringing you the atmospheric mechanics behind the forecast numbers, not just the numbers in isolation. Tomorrow I will be watching 3 things, and I want to tell you specifically what each one means for how the forecast could change. First, the ridge position, as it begins its slow westward drift. If the models show the westward movement accelerating, it means earlier relief for the mid-Atlantic, and possibly a more intense heat period for the central plains. If the drift stalls, the eastern seaboard holds the heat longer. I will be looking at the 500 millibar height anomaly maps from both the GFS and European runs first thing in the morning. Second, the disturbance off the southeastern coast, and whether it shows signs of consolidating into something the National Hurricane Center will increase its development odds on. If the NHC raises the 7-day probability from 20% toward 40 or 50%, the story changes rapidly. Third, the first Ring of Fire storm cluster tracking across the northern plains into the Great Lakes. I want to see whether it maintains its organization overnight, or whether it falls apart before reaching Minnesota and Wisconsin. The derecho potential depends entirely on whether the first cluster holds together through the night hours, the disturbance off the southeastern coast, and whether it shows signs of consolidating, and the first Ring of Fire storm cluster tracking across the northern plains into the Great Lakes. If any of those 3 evolve materially, I will be here to break it down for you in detail. Arthur is watching the data closely, and the models have spoken clearly. 200 million Americans are inside the heat zone, and the dome is not done moving. The next 5 days are dangerous. Know your resources, stay hydrated, watch out for each other. I will see you back here tomorrow.